Hello everybody and welcome to our review day 2. This is All Things Triangles part 1. Believe it or not, in geometry we have a lot of things relating to triangles, so it's going to take a couple days to get through all of it. So let's just get to it then. So first theorem to review is our Pythagorean theorem. Now this is for right triangles only, so I'm going to put a little star here. And what it is when you have a right triangle and you know two sides and you're finding the third, we know the relationship exists where we can do a squared plus b squared equals c squared, where a and b are the legs and c is the hypotenuse. Probably the biggest thing students mess up is putting the hypotenuse in the wrong place. Like they'll automatically do 5 squared plus 10 squared. But if the hypotenuse is opposite the right angle, we can see the hypotenuse is 10. So we will do 5 squared plus x squared equals 10 squared. So that's 100 minus 25, which would be 75. And let's say the directions wanted simplest radical form. I know the biggest perfect square is 25. So 5 radical 3 would be my side for x. Similar triangles. Let me actually zoom in here. Okay, so triangles are considered similar if all the corresponding angles are congruent and all the corresponding sides are congruent. So I have triangle ABC similar to triangle PQR. And it does matter the order in which you state those angles, as in A is congruent to P, B's congruent to Q, and C's congruent to R. For corresponding sides, again, it goes in the order given. There are 3 pairs here. I can do AB to PQ, BC to QR, and lastly, AC to PR. Now the ways that we will prove triangles to be similar are angle-angle, meaning if you have 2 pairs of angles congruent, then the triangles must be similar. And this makes sense because by default you'll get the 3rd pair congruent. Side-angle-side, which means that you have 2 pairs of sides, like for instance AB and AC, PQ and PR. And the angle included also congruent. Okay, if you have that, then you would have the triangle similar by side, angle, side. And then lastly, if you know that all the corresponding sides are in proportion, then the triangles must be similar. We will mostly use angle, angle when it comes to actually doing a proof. So that's the favorite. All right, coming on over to triangle side splitter theorem. So speaking of similar triangles, when you have a triangle and you draw a segment in here like EB and it's parallel to DC, it creates a small triangle and a big triangle that are then similar to each other. Okay, so now in this question, we have EB parallel to DC, and I want to find AC, which is this entire length. I'm going to call BCX. And what triangle side splitter says is when we have our information on the sides of the triangle, I can set up a proportion as part is to part, as part is to part. So 9 is to 5, as 9.2 is to x. Now from there I can cross multiply and solve. And divide by 9. Now by doing so, I would get 5.1 repeated using my calculator. Now the trick to this question again is that it doesn't want BC, it wants AC, which is our whole. So if I want this whole segment, I'd have to add the 9.2 to it. So to the nearest 10th, we'd end up with 14.3 as our final answer. And that was a Regents question that was once a multiple choice. So that's triangle side splitter theorem. If these are parallel, I can then do part is to part as part is to part. Technically, you could also do small triangle versus big triangle and solve it that way as well. You could do 9 is to 14 as 9.2 is to x and solve for x from there. All right, coming on over to our isosceles triangle theorem. What this says is if we have two sides of a triangle congruent, that means the angles opposite will also be congruent. From there, we know the sum of the interior angles of a triangle is congruent. So I can say 2x plus 40 equals 180. So 2x equals 140. So x equals 70. So these are called my congruent base angles, which I just discovered they would each be 70. The angle at the top is your vertex angle. And the sides that are congruent are called your legs. All right, talking about the exterior angle theorem next. This says an exterior angle, which is this guy right here, is equal to the sum of the remote interior angles. Now, you may have a teacher that says non-adjacent interior angles. Non-adjacent interior angles, which is the same thing as remote interior angles, okay? So again, I like to say remote interior angles. They're the angles away from the exterior angle inside the triangle. No matter what, this says that our exterior angle equals the sum of those two angles. So this is ultimately a shortcut in most places. I can just add those together and get 105. The longer way to do this problem would be to solve for this missing angle right here and then do a linear pair. It still would work, but in certain instances it makes more sense to do the exterior angle theorem, especially if I throw some more variables in here that make it more difficult to find this angle. So just be prepared for that. All right, I'm gonna scroll down. Might as well do mid-segment next. Now, mid-segment is very similar to side splitter in that a mid-segment, which is when we take the midpoints of two sides of a triangle and join them. So FE, for instance, is a mid-segment. He is parallel to AB. Now, because he's very specifically in the middle of those two sides, the mid-segment is actually half of the base that it's parallel to. Okay, so for instance, they're telling me in this picture I have FE is 6. That means that AB would be 12. He's double the mid-segment. If I tell you, here, I might change my color here, that AC, this whole section is 10, to get to its mid-segment that he would be parallel to, he would be half of 10, which is 5. So again, a mid-segment is parallel to the base, and it's half of the base that it's parallel to. All right, coming on over to interior angles of a triangle. I already briefly talked about this, but we know the sum of the interior angles of a triangle is 180. In this question, I'm going to throw a lot at you, though. In the diagram below, DE divides AB and AC proportionally. So I want to pause there for that second. In triangle side splitter, we know that if these sides are cut proportionally, where I can do part is to part as part is to part, then it must be true that DE is parallel to BC. So that's what that statement that I just underlined in pink is saying, okay? If I know that these sides are cut proportionally, then these must be parallel. So I'll put a little note here. Triangle side splitter. Okay, moving on. They got angle C is 26, angle A is 82, and then DF bisects BDE. So BDE would be here. These two angles would have to then be congruent. I want to find the measure of angle DFB. So DFB would be right there. All right, so first thing I'm personally going to do is use the fact that I have a big triangle here. And what I mean by that is you have a big triangle, ABC. Okay, so I know the sum of the interior angles of a triangle is 180. So if I do 180 minus 82 minus 26, that means angle B must be 72 degrees. So that's this angle right here. Now don't forget the parallel lines. If we have two parallel lines cut by a transversal, then that means this angle up here must also be 72 because those are corresponding angles. Now let me just call this y and y because I don't want to use the same variable twice. I know the sum of the angles that form a line is 180, so I can do 72 plus 2y equals 180 degrees and solve for y. So subtract the 72 and then divide by 2. All right, so we're almost there. So that means each of these angles is 54 degrees. Now there's two things you could do here. Once you know this is 54 and this is 72, here's another triangle. You could do the sum of the interior angles of a triangle is 180 and you could find that missing angle x. There is a shorter way though. I could focus on the fact that these are parallel and then notice I have alternate interior angles. So what must x be? X must be 54. And that is how you get there. Believe it or not, that was a multiple choice on a Regents exam a few years back at this point, but it uses a lot of good skills. Okay, so now that I've gone through all the different skills, we are going to just do some practice problems. All right, so this says use side splitter theorem to solve for x in the triangle below. So side splitter again says that if these are parallel and I have all my information on the sides, which I do, I can do part is to part as part is to part along the sides and cross multiply from there. So 50 equals 2x. So x equals 25. Now, again, I would be remiss if I didn't mention that you technically could do big triangle versus small triangle here. You have this small triangle at the top, which is a 2 and a 5. And then you have this big triangle that would create a 12 along the left side and a 5 plus x, or x plus 5. You technically could do 2 is to 12 as 5 is to x plus 5 and solve from there, but there's a little bit more algebra there to just be able to solve. In some instances, it may make more sense to do that, but I felt it was important to note that. Again, the reason why these triangles are similar is because if these two pairs of segments are parallel, I got a couple pairs of corresponding angles congruent, and technically a reflexive angle at the top, and that's why those triangles would be similar. All right, moving on to question 2. I've got midpoints of NP and OP listed, so that means these are congruent, which makes QP a mid-segment. Okay, they're telling me that QR is negative 3x plus 31, and NO is 71 minus 9x. Now remember what I said about mid-segments. The mid-segment is half of the base that it's parallel to, or you could double the mid-segment to get the base. And that's actually what I'm going to do. I'm going to take 2 and multiply it by my mid-segment and set that equal to my base of 71 minus 9x. And from there, we're ready to solve. So a little bit of distribution. Add the 9x over and I would get 3x. Subtract the 62 and that would get 9. And x equals 3. Now at the end of the day it wants QR. So I'm just going to substitute 3 in for x. And that would give me 22. So make sure when you guys do these problems you read it fully, because sometimes I don't want x, sometimes I want something else. And in this case it wanted the mid-segment. Now here's a fun little follow-up. What if then I asked you real quick what NO is? Well, if we know because of our previous work that this is 22, then this would have to be 44 because he's double the midsegment. So just a nice little follow-up there. All right, moving on to question 3. In the diagram below of triangle JML, I know that NK is parallel to ML. I want to find the length of JL. So that's this whole section. Now, I'm going to do this a little bit differently. Let's call this X. And then the corresponding distance on the other side of that triangle would be 24. Now what I can do is compare the small triangle to the big triangle. So 4 corresponds to 24, as 10 corresponds to X. And from there I can cross multiply to solve. So 4X equals 240, so X equals 60. And that's absolutely one way to do it. Okay, now another way to do it, just going to sketch another quick picture here, is what if I kept this as 4 and this is 20, and this is 10 and this is, let's call it Y. I could technically do part is to part as part is to part and solve. Okay, notice how I get Y equals 50, but that's just representing what KL is. I want JL, so you'd have to remember to add 10, and then you'd get 60. So just another way to think about that problem. So either way, you're using your information on the sides. You can do triangle side splitter with part to part equals part to part, or you could do big triangle versus small triangle. All work. All right, question 4. All right, so I'm giving you some information about the angles. I've got OPQ, which is this exterior angle, is 9x minus 19. PNO, which is right over here, is 2x plus 5. And NOP, which is right at the top, is 3x plus 16. And I want to find NPO. So that's this angle in here. All right, so what I'm going to have to do is find x first before I can even get to that missing angle. So if this is an exterior angle, I know it's equal to the sum of the remote interior angles, or non-adjacent interior angles. So I can do 2x plus 5 plus 3x plus 16 equals 9x minus 19. And then we're cleaning up some work from there. All right, so I've got 5x plus 21 equals 9x minus 19. Subtract the 5x. Add the 19. So x must be 10. Now, in order to get to the angle I highlighted in blue, probably the quickest way would be to go to my exterior angle and find out how much he is. So 9 times 10, minus 19, would be 90 minus 19, which is 71. So then from there, if I want to get to this angle right here, maybe I'll call him Y. I know 71 plus Y equals 180. So therefore, my missing angle must be 109. Now, you could have also substituted in for angles O and N and then done the sum of the interior angles of a triangle as 180, but I think that the linear pair is probably your faster route. All right, just a couple more questions. Find the length of the third side. If necessary, write it in simplest radical form. All right, so first thing I'm noticing, it's a right triangle. I know 2 sides. I'm finding the third. So this is my Pythagorean theorem. Keep in mind your hypotenuse is radical 85. So we would do a squared plus b squared equals c squared. So 49 plus x squared equals, well, anytime I have a square root times itself, I'll just get the radicand back, so this just gives me 85. Now you could always type that in your calculator, but you will get 85. Subtract the 49, get 36. This works out nicely. So if I take the square root, x is equal to 6. All right, question 6. We got triangle BCD. Let's draw a picture. Where DB equals CD. So I'm already thinking angle C is congruent to angle B because those are opposite. They're telling me angle C is 36 degrees. I need to find angle D. Well, like I said, if we know that these two sides are congruent, then that means angle C is congruent to angle B. So that means angle B must also be 36. So I know the sum of the interior angles of a triangle is 180. So I could do 72, because that's the sum of these, plus x equals 180 degrees. So therefore, x is equal to 108. All right, last question. All right, the ratio of similarity of boy to girl is 1 to 2. If boy is x plus 3 and if BO is x plus 3 and GR is 3x minus 1, what is the length of GR? Now, when we say ratio of similarity, they're telling you from boy to girl, that is 1 to 2. They're telling you, I'll put B and G here, that boy, or BO, is x plus 3. GR, which is part of a girl triangle, is 3x minus 1. So I'm comparing those two together. In order to solve, let's cross multiply. So I get 2x plus 6 equals 3x minus 1. So if I add the 1 over, I would get a 7. Subtract the 2x, I would get an x. So x is 7. Now, at the end of the day, they want what GR is. So 3 times 7 minus 1. That's 21 minus 1, which gives us 20. All right, and that is All Things Triangles Day 1, concluding our second review video of our final exam review.